Next topic in atoms and molecules chapter is mole concept. Now what is the meaning of mole concept? This is taken from a word mole. So first of all we understand what is the meaning of mole. So if I take 1 mole quantity, it's a quantity. 1 mole quantity if I'm taking, that means there are 6.022 into 10 raised to power 23 atoms in it. In this much of quantity, 1 mole, how many particles are there? These many number of particles are there, like these many number of atoms can be there. And these particles can also be molecules. But the number will remain the same, that is 6.022 into 10 raised to power 23. So if you take 1 mole of an element, in that element these many atoms are there. But if we are taking a compound, then these many number of molecules are there in its 1 mole. For example, if we are taking, for example, hydrogen element. If I am taking hydrogen element, this is made up of atoms. So in 1 mole of this hydrogen element, there are these many number of atoms. But if I take hydrogen molecule is made up of 2 hydrogen atoms. This is H2, that is hydrogen molecule. So if we take these many number of hydrogen molecules, that is equal to 1 mole. These many number of atoms of 1 mole of an element is also called gram atomic mass. This is also known as gram atomic mass. This is called atomic mass. We have already done atomic mass is a mass of atoms, or we can say this is a mass of element. So this is called gram atomic mass. And these many number of molecules, mass if we'll take, that is called gram molecular mass. This is known as gram molecular mass. And together these two, gram atomic mass and gram molecular mass, we can combine these and we can use one term for these two, that is called molar mass. That means if the mass of atoms or the molecules of these many number of atoms or molecules or 1 mole, then we will call that as molar mass, and the unit for that is the grams. We write the unit as gram. But if in place of these many number of atoms or molecules, I am just taking 1 atom of hydrogen or 1 molecule of hydrogen, if I take, then that is not called gram atomic mass or gram molecular mass. So 1 atom mass of hydrogen, for example, I am taking hydrogen element, then that is just 1 atom mass, not these many number of atoms. Then this is not known as 1 mole, because I have not taken 6.022 into 10 raised to power 23 atoms. I am taking just 1 atom. So that is known as atomic mass. This is known as atomic mass. This is not called gram atomic mass. This is called just atomic mass. Similarly, if I take 1 molecule mass of hydrogen, hydrogen molecule means H2, then that is known as molecular mass. And the unit for these masses now will not be gram, the unit for these will be atomic mass unit, that is we write these masses in U only. This is a difference between 1 atom, 1 molecule mass, and these many number of atoms and these many number of molecules mass. Now this number is a specific number. This was actually calculated by Avogadro, that if these many atoms will be taken, mass of these will be known as gram atomic mass, and these many number of molecule mass will be known as gram molecular mass. That is why this number is known as Avogadro number. This number is called which number? That is Avogadro number. Now I am combining the whole mole concept. I am writing 1 mole of an element. I am taking first of all, if we are talking about 1 mole of element, that means in that there are these many number of atoms. Any element 1 mole will take, there will always be these many number of atoms in it, and these many number of atoms mass is known as gram atomic mass. Write that mass in grams. But if I take 1 mole of molecules, if I take molecule will include compounds also. These many number of molecules, 1 mole of molecules will have these many number of molecules in it. And the mass of these is known as gram molecular mass. This is the whole mole concept. Now one example to understand this thing. I am taking first of all 1 mole of an element example I am taking. So it is 1 mole of oxygen if I take. 1 mole of which element I am taking? Oxygen. In that, how many oxygen atoms are there? 6.022 into 10 raised to power 23 atoms are there. And mass of 1 mole of oxygen or mass of these many atoms of oxygen is equal to its gram atomic mass. We have learned atomic mass of oxygen as 16, but now I am writing the unit as grams here because this is the mass of these many atoms, so it should be gram atomic mass written in grams. Now next is 1 mole of molecule. 1 mole of oxygen molecule if we will take, I am writing O2, that means its molecule. In this there will be how many molecules? These many number of molecules. And the mass of this is 16 into 2, 32, and unit what we write is, we write grams for this. So this is the difference between the atoms and the molecules, and these masses, gram atomic mass and the gram molecular mass, and we have learnt how to calculate the molecular mass. Now some formulas to solve mole concept questions. N is for moles. Small n term we are using it for the mole. The symbol N is equal to atoms if we are talking about elements upon Avogadro number of atoms, that is 6.022 into 10 raised to power 23. So we will find out the mole if we will take the atoms given the question and divide it with Avogadro number. Or if moles are given, we can find out atoms using this formula. So this formula we'll use if we are talking about moles and atoms in the question. Second formula is moles. They are also equal to mass upon gram atomic mass. Again, this is for elements only because we are using atomic mass term here. So this is the mole of element. Next is moles are also equal to, if you're talking about molecules, then in place of atoms here we'll write molecules and divided with again 6.022 into 10 raised to power 23. And then this formula we are using N moles for the molecules. Now mass upon, since it is molecules, we will divide it with the gram molecular mass. Now see this first, second, third and fourth formula. Next formula. Now here these two formulas we are taking. This is for the mole of element, mole of element. If these sides are equal, these two also will be equal to each other. So another formula we'll get by equating these two equal to each other. So atoms upon 6.022 into 10 raised to power 23 is equal to mass upon gram atomic mass. Similarly, these are moles of molecules. So if these sides are equal, these two also will be equal to each other. So we are getting the sixth formula, molecules upon Avogadro number equal to mass upon gram molecular mass. So this is the fifth formula and this is the sixth formula. So many numericals we can solve using these formulas directly, or sometimes we need to use the unitary method also. So let's start with the questions after these formulas. First question is, calculate the number of moles for the following. We have to find out the moles for the following. Now see, moles we have to find out and mass is given, and this is element. So we have to use the formula of element where we have moles and mass. See the formula where we have mole and mass. This is the formula for element, mole and mass. This formula I am using, mole equal to mass upon gram atomic mass. Mole equal to mass upon gram atomic mass. Now gram atomic mass of helium, since element mentioned here is helium, is equal to 4 grams. And mass given is how much? 52. mass is equal to 52 grams. Fill these values in the formula. We get mole equal to 52 divided by 4. So this one is equal to 13 moles is the answer. So using the formula directly also we can find out. Moving on to the next part, beta. See, these many number of atoms are given and we have to find out the moles. So formula here will be moles we know are equal to atoms upon 6.022 into 10 raised to power 23. We are using this formula because in the question we have moles and atoms, and this has moles and atoms. Moles we have to find out. These many number of atoms are given. So fill the value here. This will cancel out. This one will be equal to 2. So answer is 2 moles. Now next question, we have to find out the mass now. In the first part, moles are given. So now formula we have to take where mole and mass they are given. So we know mole is equal to mass upon gram molecular mass I have written because molecule is given here. And gram molecular mass of N2 I have calculated 28 grams. Fill 28 grams here. And moles are given, fill moles 0.5. 0.5 into 28 will give us the mass of the N2, that is 14 grams. Next question, moles are given and mass we have to find out, but now atoms are here. So in the formula we write gram atomic mass in place of gram molecular mass. How many moles are there? 0.5. Mass we have to find out, and we need gram atomic mass of nitrogen, that is 14. So gram atomic mass of N is equal to 14. So 14 into 0.5 will be equal to mass. Answer is 7 grams. Next is third part. These many number of nitrogen atoms are given and we have to find out the mass. So we need the formula where we have mass and atoms given. So mass upon gram atomic mass is equal to atoms upon Avogadro number. This formula we will use. And gram atomic mass of nitrogen we need, that is 14 grams. Fill the value here. Mass we have to find out. Gram atomic mass is 14. And how many atoms are given? 3.011 into 10 raised to power 23 upon Avogadro number. So this one is mass is equal to 14 by 2, that is 7 grams is the answer. Fourth part. Now here these many number of molecules are given. So mass we have to find out, formula is mass upon gram molecular mass. Now we'll write here, and here we write molecules upon Avogadro number. Gram molecular mass of nitrogen we know is equal to 28 grams. Fill the value here. Mass we have to find out. 28 into molecules given are Avogadro only. These will cancel out better. And mass will be equal to 28 grams, which is the answer.